February 20th, 1944. Majuro Atoll, Marshall Islands. Lieutenant Commander Eugene C. Richardson squinted through his binoculars at the coral reef stretching endlessly toward the horizon. The water was crystal clear, revealing every detail of the jagged coral formations beneath the surface. What he was contemplating would have seemed impossible to any reasonable engineer. In 72 hours, this pristine atoll would need to support fully loaded B-24 Liberators taking off for strikes against Japanese positions 800 miles away. There was no runway. There was no airfield. There was nothing but coral, sand, and the determination of 1,200 Seabees who were about to rewrite the rules of military engineering. Richardson commanded the 99th Naval Construction Battalion, one of the most experienced Seabee units in the Pacific. His men had built airstrips on Guadalcanal under artillery fire. They had carved harbors from solid rock on volcanic islands. They had performed engineering miracles that conventional wisdom said were impossible. But this assignment pushed beyond even their extraordinary capabilities. The coral atoll measured barely 400 yards at its widest point. The highest elevation was 12 feet above sea level. The foundation was nothing but coral sand that shifted with every tide. Any conventional engineering approach would require months of preparation, massive equipment, and materials that simply did not exist in the middle of the Pacific Ocean. Richardson's orders were unambiguous. The airstrip would be operational in 72 hours. B-24 bombers would begin operations immediately upon completion. The Japanese garrison at Truk, just 800 miles northwest, represented the most heavily fortified position in the Central Pacific. American strategy demanded that Truk be neutralized before the invasion of the Mariana Islands could proceed. The bombers based at Majuro would provide the striking power necessary to reduce Japanese defenses. Everything depended on Richardson's Seabees accomplishing what every engineering manual said was impossible. The Seabees had emerged from America's recognition that modern warfare demanded more than traditional military engineering. Created in 1942 by Admiral Ben Moriel, the Naval Construction Battalions recruited skilled tradesmen from civilian life. Carpenters, electricians, heavy equipment operators, concrete finishers, welders, and demolition experts were given military training and deployed to combat zones where their skills were desperately needed. The name Seabees came from the phonetic pronunciation of the Construction Battalion abbreviation CB. Their motto became legendary throughout the Pacific Theater. The difficult we do immediately, the impossible takes a little longer. By early 1944, Seabee battalions had proven their worth across dozens of Pacific islands. They had built the airstrips that launched the Doolittle raid. They had constructed the harbors that supplied American offensives. They had carved roads through jungle terrain that military maps showed as impassable. But the assignment at Majuro represented challenges that exceeded anything they had faced. The coral atoll offered no natural building materials. Fresh water was limited to what could be collected from rainfall. Heavy equipment would have to be brought by landing craft across 2,000 miles of ocean. Every ton of construction material would have to be shipped from bases in Hawaii or Australia. Richardson's first challenge was determining whether the coral foundation could support the weight of fully loaded bombers. B-24 Liberators weighed 65,000 pounds at maximum takeoff weight. The main landing gear distributed this weight across relatively small contact patches, with ground pressure exceeding 80 pounds per square inch. Conventional runways used concrete or asphalt over engineered foundations, capable of supporting these loads indefinitely. Richardson had coral sand that might shift or collapse under the first aircraft to attempt landing. His solution would revolutionize military airfield construction for the remainder of the war. Instead of trying to create conventional foundations, Richardson's engineers would use the coral itself as building material. The atoll contained millions of tons of coral in various stages of decomposition. Fresh coral was too hard to work with existing equipment. Decomposed coral was too soft to provide structural strength. But coral in intermediate stages of weathering offered unique properties that could be exploited with proper techniques. The key breakthrough came from Chief Petty Officer Marcus Webb, a concrete finisher from Detroit who had worked on major construction projects before the war. Webb discovered that partially decomposed coral, when crushed and mixed with seawater, created a cement-like compound that hardened to remarkable strength. The process required precise timing and mixture ratios. Too much water, and the compound remained soft. Too little water, and it would not bind properly. But when mixed correctly, coral concrete achieved compressive strength approaching conventional Portland cement. Richardson ordered his men to begin experimental batches immediately. The coral had to be harvested from specific areas of the reef where weathering had progressed to optimal stages. Heavy equipment operators used bulldozers equipped with special blades to scrape coral from the reef surface. The harvested material was transported to crushing stations where portable rock crushers reduced it to uniform aggregate sizes. The crushing operation ran continuously, with different crews working around the clock to maintain production schedules. The mixing process demanded precision that would have challenged experienced concrete contractors. Each batch required exact proportions of crushed coral, seawater, and additives that Richardson's chemists had developed through trial and error. The seawater itself presented complications because salt content varied with tides and weather conditions. Fresh batches had to be tested continuously to ensure consistent strength properties. The mixing equipment, designed for conventional concrete, required modifications to handle the abrasive coral aggregate. While concrete production proceeded, other Seabee teams prepared the runway foundation. The coral atoll's irregular surface had to be leveled and graded to precise specifications. Surveyors worked with primitive equipment to establish grade lines across terrain that shifted with every high tide. The foundation required drainage systems to prevent water accumulation that could undermine the concrete surface. French drains were constructed using crushed coral, wrapped in canvas, salvaged from tents and tarps. The runway dimensions were calculated to accommodate B-24 operations with minimal safety margins. Length was established at 6,000 feet, sufficient for fully loaded bombers under normal conditions, but leaving no room for error. Width was limited to 150 feet, narrow by conventional standards, but adequate for experienced pilots. The entire runway would consume more than 8,000 cubic yards of coral concrete, requiring continuous production for the entire 72-hour construction window. Japanese reconnaissance aircraft had been observed over the Marshall Islands with increasing frequency. Intelligence reports suggested that Japanese commanders understood American intentions and were planning countermeasures. The construction schedule allowed no time for delays caused by air attacks or equipment failures. Every hour counted toward meeting the impossible deadline that military necessity had imposed. Richardson divided his battalion into specialized teams working simultaneous operations. Team Alpha handled coral harvesting and crushing. Team Bravo managed concrete mixing and transport. Team Charlie prepared foundations and drainage systems. Team Delta operated heavy equipment for grading and surface preparation. Each team worked 8-hour shifts with overlapping schedules that maintained continuous operations. The Coral Atoll became a 24-hour construction site, with activity proceeding under floodlights when darkness fell. The logistics of the operation strained every aspect of Seabee capability. Fuel consumption exceeded all projections as heavy equipment operated continuously. Fresh water for concrete mixing had to be supplemented with emergency supplies flown in from distant bases. Replacement parts for crushing equipment were fabricated on site using welding equipment and salvaged materials. The concrete mixing operation alone required more resources than many Seabee battalions used for entire airfield projects. Equipment failures threatened to derail the entire schedule. The primary rock crusher suffered bearing failure after 18 hours of continuous operation. Chief Webb and his mechanics worked through the night fabricating replacement parts from salvaged metal. The concrete mixer experienced hydraulic problems that reduced mixing capacity by 40%. Backup equipment was pressed into service while repairs proceeded simultaneously with ongoing operations. Human endurance became a critical factor as the 72-hour deadline approached. Seabees worked shifts that exceeded normal limits, sustained by coffee, determination, and the knowledge that bomber crews were depending on their success. Medical personnel treated injuries caused by fatigue and equipment accidents. Heat exhaustion became common as tropical temperatures combined with physical exertion that pushed men beyond their normal capabilities. The Japanese response began on the second day of construction. Reconnaissance aircraft appeared over Majuro at regular intervals, photographing the construction progress and reporting to Japanese commanders at Truk. The flights confirmed that American forces were building a major airfield within striking range of Japan's most important Central Pacific stronghold. The implications were obvious to both sides. Once operational, the Majuro airstrip would launch continuous attacks against Japanese positions that had been considered beyond American reach. The first Japanese counterattack came at 0300 hours on February 22nd. 6 Nakajima, B-5N. Kate torpedo bombers approached Majuro from the northwest, flying at wave-top height to avoid radar detection. The aircraft carried 250-kilogram bombs instead of torpedoes, configured for ground attack against the construction site. Seabees sentries spotted the incoming formation just minutes before the attack commenced. Richardson had anticipated this moment. Every construction operation in the Pacific faced the same dilemma. The more progress you made, the more attractive a target you became. The Japanese understood that destroying the airfield during construction would be far easier than attacking it once operational. Defensive preparations had proceeded alongside runway construction from the moment boots hit coral. The Seabees had positioned .50 caliber machine guns at strategic points around the construction site. These weapons were operate-housed by men. Primary job was operating bulldozers and concrete mixers, but who had received combat training during their stateside preparation. When the Kate bombers swept in at 200 feet altitude, tracers from a dozen machine gun positions converged on the attacking aircraft. The lead bomber took hits across the engine cowling and burst into flames before reaching the bomb release point. The aircraft cartwheeled into the lagoon in a spectacular explosion that illuminated the entire atoll. The second bomber managed to drop its payload, but the bombs fell wide of the construction area, exploding harmlessly in the coral sand 200 yards from the nearest equipment. Return fire from Seabees positions damaged 2 additional aircraft, though both managed to escape toward the northwest. The attack lasted less than 5 minutes, but it demonstrated the precarious nature of the Seabees mission. The Japanese would return with larger forces once they understood the strategic implications of an operational airfield at Majuro. Every hour that passed without completing the runway increased the likelihood of facing attacks that could destroy months of work in minutes. Richardson assessed the damage while his men resumed construction operations. 1 concrete mixer had been damaged by bomb fragments, reducing production capacity at a critical moment in the construction schedule. 2 Seabees had been wounded by shrapnel, though both refused evacuation and continued working with field dressings. The psychological impact was more significant than the physical damage. Every man on the atoll understood that they were racing against time, while Japanese planners prepared more substantial countermeasures. The concrete pouring operation began during the 3rd day, as runway foundation preparation reached completion. This phase demanded precision that exceeded normal construction standards. The coral concrete had to be poured in continuous strips to prevent weak joints that could fail under the stress of bomber operations. Each section required careful leveling and finishing while the material remained workable. The tropical heat accelerated curing time, leaving narrow windows for achieving proper surface texture. Chief Webb supervised the finishing operation with obsessive attention to detail. The runway surface had to be smooth enough for high-speed aircraft operations, but textured sufficiently to provide tire traction during landing and takeoff. Too smooth an aircraft would skid during braking. Too rough and tire wear would ground bombers after minimal operations. The balance required experienced judgment applied to materials that no construction manual had ever addressed. The coral concrete behaved differently from conventional materials in ways that challenged every assumption about airfield construction. Curing time varied unpredictably based on coral composition and ambient temperature. Surface hardness developed unevenly, creating patches of varying strength that could cause catastrophic failures. The salt content from seawater mixing created corrosion concerns for aircraft aluminum components. though immediate operational requirements outweighed long-term durability considerations. Japanese reconnaissance flights increased in frequency as the runway neared completion. Intelligence reports suggested that enemy commanders were assembling strike forces at Truk for major attacks against the Majuro construction site. The window for completing the airfield before facing overwhelming opposition was closing rapidly. Richardson pushed his men beyond normal endurance limits while maintaining the precision necessary for safe bomber operations. The final concrete section was poured at 1400 hours on February 23rd, exactly 71 hours after construction commenced. The runway stretched 6,000 feet across the coral atoll, its grey surface contrasting sharply with the brilliant blue of the surrounding lagoon. But concrete completion represented only the beginning of making the airstrip operational. Navigation aids, fuel storage facilities, maintenance areas, and defensive positions all required installation before bombers could begin operations. Fuel storage presented unique challenges that conventional airfield design had never addressed. B-24 bombers required massive quantities of aviation gasoline for missions against distant targets. Standard fuel storage used underground tanks that were impossible to construct in coral sand, barely above sea level. Richardson's engineers developed above-ground storage using steel drums connected by flexible hoses that could accommodate tidal movement of the foundation. The fuel distribution system extended across the entire airfield through buried pipelines that required constant monitoring for leaks. Saltwater intrusion could contaminate aviation fuel and cause catastrophic engine failures during critical mission phases. Pumping stations were positioned at intervals calculated to maintain fuel pressure throughout the system, while providing redundancy if individual stations failed during combat operations. Navigation equipment installation proceeded simultaneously with fuel system construction. The primitive radar sets and radio beacons available in 1944 required precise positioning to provide effective guidance for returning bombers. Equipment placement had to account for tidal variations that could affect signal propagation. Power generation for electronic systems demanded diesel generators that consumed additional fuel and required maintenance capabilities that strained Seabee resources. The first test aircraft arrived at 0800 hours on February 24th. A single B-24 Liberator approached from the southeast, its pilot conducting visual inspection of the runway before attempting landing. The bomber circled the atoll twice while the crew assessed surface conditions and wind patterns. From the ground, Richardson watched through binoculars as the aircraft lined up for its approach, knowing that the next few minutes would determine whether 72 hours of impossible construction had succeeded or failed. The B-24 touched down at the threshold with perfect precision, its main landing gear making contact with coral concrete that had been liquid just hours earlier. The aircraft rolled straight down the center line as its pilot applied brakes gradually, testing surface traction and structural integrity simultaneously. Reverse thrust from the 4 Pratt & Whitney engines created clouds of coral dust that obscured the bomber until it slowed to taxi speed. The landing was flawless. The runway held. The impossible had been accomplished. Within hours, additional bombers began arriving from bases across the Pacific. Each aircraft carried fuel, ammunition, spare parts, and personnel necessary for immediate combat operations. The Majuro airstrip transformed from construction site to operational airbase with efficiency that amazed even experienced Seabee personnel. Ground crews serviced bombers, while concrete continued curing beneath their wheels. The first combat mission launched at dawn on February 25th. 18. B-24 Liberators, loaded with 500-pound bombs, departed Majuro for attacks against Japanese installations at Truk. The bomb horizon Walbers disappeared over the northwestern Seabees, continued constructing facilities that would support sustained operations against enemy strongholds throughout the Central Pacific. Japanese commanders at Truk received reports of the successful American airfield construction with growing alarm. Intelligence assessments confirmed that enemy bombers operating from Majuro could reach any Japanese position within an 800-mile radius. The strategic balance in the Central Pacific had shifted overnight through the impossible achievement of 1,200 Seabees who had built a runway from nothing but determination and coral sand. The psychological impact on Japanese forces became apparent within days of the first bombing missions. Radio intercepts revealed confusion and dismay among enemy commanders who had considered their Truk stronghold beyond American reach. Lieutenant Colonel Takeshi Yamamoto, commanding the 105th Air Regiment at Truk, transmitted desperate requests for reinforcements to Tokyo. His messages, decoded by American intelligence, painted a picture of an enemy suddenly vulnerable after years of strategic security. The bombers launching from Majuro carried more than explosives. They carried proof that American engineering capability could overcome any natural obstacle through sheer determination and industrial might. Each mission demonstrated that distance no longer provided protection for Japanese positions. The Coral Runway represented a fundamental shift in Pacific warfare, transforming isolated atolls into unsinkable aircraft carriers positioned wherever American strategy demanded. Richardson's success at Majuro established templates that Seabee battalions would employ across the Pacific theater. The coral concrete technique developed by Chief Webb became standard procedure for rapid airfield construction on coral atolls. The 72-hour construction timeline proved that impossible deadlines could be met through continuous operations and innovative engineering solutions. Most importantly, the Majuro project demonstrated that American forces could project air power anywhere in the Pacific Ocean, given sufficient determination and resources. The Japanese response escalated rapidly as enemy commanders recognized the strategic implications. On February 27th, 43 Japanese aircraft launched from Truk in the largest counterattack attempted against American positions since the Guadalcanal campaign. The formation included twin-engine Betty bombers, single-engine Val dive bombers, and Zero fighters configured for long-range operations. Their target was the Majuro airstrip and the bombers based there. American radar stations detected the incoming formation at maximum range, providing 37 minutes of warning before the attack commenced. The B-24 crews scrambled to get their aircraft airborne, while Seabee defensive positions prepared for the assault. Richardson had positioned his men in foxholes and gun emplacements, constructed from coral and steel, salvaged from construction operations. Every available weapon from pistols to heavy machine guns was aimed at the northwestern horizon, where death approached at 250 miles per hour. The Japanese attack began at 14:20 hours with dive bombers screaming down from 8,000 feet. Their 250-kilogram bombs cratered the runway surface in multiple locations, sending chunks of coral concrete flying like shrapnel. The explosions created clouds of dust and debris that obscured visibility across the entire airfield. Through the chaos, Seabee gunners maintained disciplined fire at targets that appeared and disappeared in the smoke and confusion. One Val dive bomber, damaged by anti-aircraft fire, crashed directly into the fuel storage area. The explosion ignited aviation gasoline in a fireball that rose 300 feet above the atoll. Secondary explosions followed as fuel drums cooked off in the intense heat. Black smoke billowed across the construction site, creating an apocalyptic scene that tested every man's courage and training. Yet the Seabees continued fighting while their months of work burned around them. The Betty bombers arrived at medium altitude, their bombardiers targeting the runway intersection, where the most damage could be inflicted. Their bombs fell in tight patterns that demonstrated the skill and training of veteran Japanese air crews. Each explosion sent tons of coral concrete flying in all directions. The runway surface that had required 72 hours of continuous labor was being systematically destroyed in minutes. But the Japanese had underestimated both the structural integrity of coral concrete and the determination of American construction crews. The runway cratering, while extensive, did not penetrate to the foundation level. The underlying coral aggregate remained intact, providing a base for rapid repairs that could restore operations within hours rather than days. Richardson assessed the damage while fires still burned, calculating repair requirements even as the attack continued overhead. The Zero fighters strafed anything that moved, their 7.7mm machine guns raking the construction equipment and defensive positions. Seabees dove for cover behind bulldozers and concrete mixers, while tracer rounds sparked off metal surfaces. Chief Webb, caught in the open during the initial attack, rolled under a steamroller and continued directing concrete operations by shouting instructions to his crew over the sound of gunfire and explosions. The air battle above Majuro demonstrated the strategic value of the airfield, even while under attack. American fighters from the Carrier Task Force intercepted Japanese aircraft during their withdrawal, shooting down 14 bombers and fighters before the enemy formation could reach the safety of Truk. The engagement proved that Japanese air power, stretched across vast Pacific distances, could not sustain the losses necessary to neutralize American airfield construction. When the smoke cleared and the last Japanese aircraft disappeared toward the northwest, Richardson surveyed damage that would have discouraged any reasonable commander. The runway was cratered in 17 locations. The fuel storage area was completely destroyed. 2 concrete mixers were burning wrecks. 14 Seabees required medical evacuation. The communications equipment was damaged beyond field repair. By conventional standards, the airfield was out of action indefinitely. Richardson called his section leaders together in a bomb crater that served as an impromptu command post. His orders were characteristically direct. The runway would be operational by dawn. Bomber missions would resume on schedule. The Japanese attack had delayed American operations by exactly 12 hours. His men looked at the devastation surrounding them and began calculating material requirements for repairs that defied rational engineering practices. The repair operation commenced while fires still smoldered across the construction site. Crater filling required coral concrete mixed to specifications that had to be estimated without proper testing equipment. The destroyed concrete mixers were replaced by improvised systems using salvaged drums and hand tools. Fuel for heavy equipment was rationed from emergency reserves, while new storage facilities were constructed using techniques developed during the original airfield construction. Seabee ingenuity reached legendary proportions during the overnight repair operation. Welding equipment damaged by bomb fragments was repaired using spare parts fabricated from destroyed machinery. Electrical systems were rewired using cable salvaged from wrecked aircraft. The runway surface was restored using coral aggregate harvested from bomb craters, turning destruction into construction material through American resourcefulness and determination. The most critical challenge was restoring fuel storage and distribution systems before bomber operations could resume. The original installation had been completely destroyed, requiring emergency solutions that pushed engineering improvisation beyond normal limits. Steel drums were connected with flexible hoses to create temporary storage that could be expanded as materials became available. Pumping systems were assembled from salvaged components and operated manually when electrical power was unavailable. Japanese reconnaissance aircraft returned throughout the night, photographing the repair progress and reporting to enemy commanders at Truk. The intelligence confirmed what Japanese planners feared most. American construction capability could overcome any level of damage through continuous operations that never stopped, regardless of enemy action. The strategic implications were devastating for Japanese defensive planning throughout the Central Pacific. At 05:45 hours on February 28th, the first B-24 Liberator attempted landing on the repaired runway. The pilot approached cautiously, uncertain whether the overnight repairs could support full bomber weight. The aircraft touched down smoothly, its landing gear making contact with coral concrete that was still curing. The bomber rolled to a stop without incident, proving that American engineering had once again accomplished the impossible under combat conditions. Within 2 hours, 18 bombers were airborne for the second major raid against Truk. The Japanese stronghold, considered impregnable just days earlier, now faced continuous attack from aircraft operating from a coral atoll that military maps had shown as uninhabitable. The strategic transformation was complete. American air power could now reach any target within 800 miles of Majuro, fundamentally altering the balance of power across the Central Pacific theater. The success at Majuro established Richardson and his Seabees as legends throughout the Pacific Fleet. Their achievement proved that American industrial might and engineering innovation could overcome any natural obstacle when applied with sufficient determination and resources. The Coral Runway became a symbol of American capability that inspired similar projects across dozens of Pacific islands. The Seabees at Majuro had accomplished more than building a runway. They had demonstrated that American determination could transform barren coral into unsinkable aircraft carriers, that impossible deadlines became achievable through relentless innovation, and that Japanese defensive calculations meant nothing when confronted by men who simply refused to accept failure. The coral concrete beneath those B-24 bombers represented the physical manifestation of industrial democracy defeating military authoritarianism, one shovelful at a time.